Many of today's helicopters are reaching old age, moving closer to the limits of their operational life. Replacing them with more modern, efficient platforms is expected to reduce long-term costs while greatly improving mission safety. To achieve this, several contracts have been awarded to competing prototypes that are currently undergoing extensive testing and evaluation. At the heart of this effort is Sikorsky's X2 technology, a revolutionary collection of innovations created to greatly improve helicopter performance and redefine what rotorcraft can accomplish. With speeds above 200 knots and nearly double the range of conventional helicopters, X2-powered aircraft arrive at the battlefield quicker and remain operational longer. One of the most advanced aircraft built around this technology is the Sikorsky S-97 Raider, a high-speed compound helicopter developed for the Army's Future Vertical Lift program. It can transport 6 soldiers, carry external weapons, and cruise at more than 220 knots, almost twice the speed of standard helicopters, while still performing in extreme high and hot conditions such as 10 Row 0 FD and 95 heat. Advanced fly-by-wire controls, integrated systems, and a rigid rotor design give the Raider outstanding agility, allowing it to maneuver accurately through complex, low-altitude environments. Unlike conventional helicopters, it can speed up and slow down without changing its attitude, keep its focus locked on target, and even reverse propeller thrust to dive or reduce speed. Capabilities that minimize exposure time and increase combat effectiveness. Its high turn rate cuts engagement distances in half, while its ability to hover nose up or nose down allows operators to direct sensors and weapons in confined urban or mountainous terrain. This is the S-97 Raider from the Lockheed Martin Company, and it is truly the sports car of helicopters. Flying this aircraft is an incredible experience. X2 technology means ×2. We have 2 rotor systems that allow us to fly twice as fast. And why do we need 2 rotor systems? Traditional helicopters experience something called retreating blade stall, where at very high speeds, the blade moving away from the nose or retreating experiences airflow in the wrong direction across the airfoil. That simply cannot generate lift effectively. But with 2 rotor systems, one blade is always advancing on both sides of the aircraft, allowing us to fly much faster than a conventional helicopter ever could. Alright, this is the S-97's pusher propeller. And this is what sets the S-97 apart from traditional helicopters, the ability to use an independent thrust control system. We can rely on this to accelerate, reaching speeds beyond other helicopters, but we can also use it to slow down, so that when we're transitioning into a hover, in most helicopters, you have to lift the nose upward, and at that moment, you lose sight of where you're headed. Now I can always see where I'm going because I can apply the brakes, or basically deploy a parachute, by adding negative pitch to my pusher propeller. Raider also features a whisper mode, disengaging its propeller to reduce noise and approach targets without being detected. With more than 600 km of range, over 2.7 hours of endurance, aerial refueling capability, and a weapons payload including Hellfire missiles, rockets, and heavy machine guns, it's built for outstanding multi-mission flexibility. From light attack and armed reconnaissance to close air support and combat search and rescue, the platform is engineered to meet and exceed the demands of the U.S. Army's Future Attack Reconnaissance Aircraft program while remaining adaptable across joint forces and even unmanned operations. Funded entirely by Sikorsky and Lockheed Martin, Raider marks a major shift in how helicopters fight, survive, and dominate the modern battlefield. Another strong competitor is the SB1 Defiant, a joint project between Sikorsky and Boeing for the Army's Future Vertical Lift program. The partnership, established in 2013, divided responsibilities between the 2 companies, with Sikorsky leading the design and Boeing managing the propulsion systems. The larger program is intended to deliver 2 aircraft variants, a Future Attack Reconnaissance platform and a long-range assault aircraft. Their solution is the SB1 Defiant, a compound helicopter equipped with coaxial rotors and a rear pusher propeller. The Defiant has completed extensive testing to expand the limits of rotorcraft performance. Achieving speeds above 247 knots, it stands among the fastest helicopters ever built, reshaping expectations for modern vertical lift platforms and establishing a new standard for speed. It has also demonstrated a range beyond 300 miles while carrying payloads exceeding 4,000 pounds, successfully meeting the Army's demanding FLRAA requirements. One of its greatest strengths is its ability to fly extremely close to the ground, often between 50 and 100 feet. This low-level flight profile makes detection much harder for both radar systems and visual observers, improving survivability while allowing the aircraft to use surrounding terrain as cover. During one remarkable test, the aircraft performed a near-vertical deceleration from 236 knots into a confined landing zone. This maneuver showcased its exceptional agility and precise control under extreme conditions. Its maximum speed of 247 knots marks a significant milestone in its development and demonstrates its ability to surpass Army performance expectations. Another aircraft the Army evaluated was the Bell 360 Invictus. Built for tomorrow's battlefield, it was designed to deliver higher speed, greater range, outstanding agility, and deadly precision while working seamlessly with ground forces and dominating the information battlefield. Its lift-sharing wing reduces rotor workload, enabling higher speeds, while a supplemental power unit improves performance during cruise, hover, and combat situations. A low-drag tandem cockpit improves visibility and survivability. And a fly-by-wire system, already proven on advanced Bell aircraft, provides next-generation control, including pilot-optional capabilities with integrated weapons such as a 20 mm cannon and air-launched effects. The Invictus was designed to attack quickly and remain in the battle. From Raider X to Defiant and Bell's 360 Invictus, the Army pushed a new generation of aircraft to their limits, evaluating speed, range, and real-world capabilities. Then, in 2024, it made an unexpected decision. Rather than choosing a winner, the Army canceled the entire program, highlighting a shift toward drones and unmanned systems replacing reconnaissance missions that were once performed by crewed helicopters. But the journey didn't stop there. Through a separate competition for long-range assault, one aircraft continued to move ahead, providing greater range, faster speeds, and a more proven, lower-risk design after years of evaluation. This is the aircraft that transformed the future of assault, the V-280 Valor. Now officially named the MV-75, where MV represents multi-mission vertical takeoff, and 75 honors the Army's founding year, 1775. In December 2022, the Army completed its selection, choosing Bell's advanced tiltrotor aircraft to become the foundation of Army aviation for decades ahead. The MV-75 is designed to provide soldiers with a major advantage, combining the long-distance speed of a turboprop with the maneuverability of a helicopter, capabilities that are becoming increasingly important on a rapidly changing battlefield. At its heart, this aircraft is designed around the modern warfighter, offering dramatically improved flight performance while also lowering long-term maintenance and operational expenses. Unlike conventional helicopters, tiltrotor technology enables the MV-75 to travel faster and farther while preserving the agility needed for demanding missions. It is a platform created for multi-domain operations, where speed, range, and survivability can determine mission success. The aircraft's fixed-engine configuration simplifies production and improves reliability while also reducing the demands placed on pilots during intense situations. Extensive flight evaluations have already shown outstanding control in pitch, roll, and yaw, demonstrating the agility needed in real combat environments. And with more than twice the speed and range of many existing Army aircraft, the MV-75 delivers a significant advancement in long-range assault capability. Ultimately, this is not simply a new aircraft. It is a complete transformation in how the U.S. Army intends to project power, transport forces, and succeed on the battlefield of tomorrow. To make sure the aircraft satisfies real operational requirements, Bell invited soldiers from the 101st Airborne Division to examine the design directly. These troops inspected the cabin, evaluated seating arrangements, and reviewed overall usability. Their input is extremely important because they are the actual users who will operate the aircraft every day. Very well. By applying this feedback, Bell is working to create a platform that is easier to operate, simpler to maintain, and more effective for military missions. The Army is not only developing next-generation helicopters, it is also improving its ground capabilities with vehicles like the Infantry Squad Vehicle Heavy, designed to increase tactical mobility during modern combat operations. Built to transport up to 6 soldiers, the vehicle enables infantry units to move rapidly across challenging terrain while remaining protected and prepared for missions. What makes the ISF particularly valuable is its integrated power system, which can operate radios, sensors, and other essential equipment directly from the vehicle. This capability is vital for today's distributed battlefield, where smaller units frequently operate away from larger support networks by delivering both mobility and dependable power. The IV allows squads to maintain communications, use advanced equipment, and remain effective throughout extended operations. The vehicle's design emphasizes speed, adaptability, and quick deployment, allowing troops to rapidly reposition across the battlefield and respond to emerging threats. Based on the tough Chevrolet Silverado platform, this squad vehicle integrates military modifications, advanced suspension, and hybrid power technology to quickly transport troops through harsh environments while improving efficiency, endurance, and battlefield movement. Along with the heavy variant, the U.S. Army also uses the Infantry Squad vehicle, a lightweight, unarmored transport vehicle designed to quickly move soldiers across the battlefield. The Infantry Squad Vehicle, or ISV, is transforming how the Army deploys its troops. Lightweight, agile, and designed to reach areas where heavier vehicles simply cannot go. The U.S. Army has purchased 121 additional Infantry Squad vehicles through an $18.8 million contract, with the overall program value potentially increasing to $458.4 million. Earlier this year, senior Army officials presented a challenge to Applied Intuition, a Silicon Valley company focused on autonomous technologies. The objective: take commercial self-driving technology and rapidly convert it into a combat-ready military platform. In only 10 days, the team produced a fully autonomous IV connected with a Humvee mobile command center. It provided a clear example of what happens when military requirements combine with Silicon Valley innovation speed. Here at this jerk rotation with the Applied Intuition team, we have an autonomous IV. They came to our offices and gave us 10 days to modify a military vehicle and integrate Applied Intuition technology, our off-road autonomy system, and our Vehicle OS platform. The goal is to make military vehicles more intelligent. We help them move faster and overcome much of the approval process that normally delays getting new technology into soldiers' hands. We used a contract method called a CRADA, or Cooperative Research and Development Agreement. It can transmit its camera footage anywhere in the world, wherever a commander needs to monitor the operation. It includes built-in target recognition systems, allowing it to identify possible threats nearby and send that information back. It can also recognize maintenance problems and detect vehicle failures, including low tire pressure, engine cooling issues, and engine temperature warnings. It will notify operators when a problem appears and guide soldiers through the repair process. The vehicle can also receive a vehicle operating system, allowing other companies to integrate their technologies while supporting MMPs or multi-mission payloads. For example, a soldier could request a robotic mortar system, require CASEVAC support, or use an ATAC capability to call the autonomous vehicle for assistance. These are the different possibilities we are exploring. The vehicle can be sent ahead independently to scout a route and identify potential problems before a unit moves forward. We are working to introduce these advanced methods and technologies while partnering with soldiers so they can have the same level of capability they experience with personal technology in the vehicles they operate and the equipment they use. We want their equipment to be the most advanced in the world. The IV is an official Army program of record awarded to GM Defense to satisfy confirmed operational requirements. Based on the Chevrolet Colorado ZR2 platform, it uses 90% commercially available components. This combination of reliable automotive parts and military-focused engineering makes it durable and simple to maintain while reducing expenses and unnecessary complexity. Off-road capability is where the IV truly stands out. Chevrolet performance enhancements allow it to climb challenging slopes, move through mud and sand, and overcome difficult terrain with confidence. The infantry squad vehicle is essentially a high-mobility platform designed to transport troops and equipment from one location to another, bringing soldiers as close to the objective as possible so they can dismount and engage the enemy without spending too much time moving on foot while carrying heavy loads. I would say it allows us to fight with less weight. As a light infantry division, we depend on our ability to move on foot during combat. However, because we also carry a wide range of weapon systems like AT-4s and javelins, fighting dismounted becomes challenging. With these vehicles, we can carry all of our supplies, equipment, and weapons, then move close to the objective, get out, and continue fighting while staying light and mobile. All the heavy gear we carry, including our rucksacks, javelin systems, AT-4s, Carl Gustavs, Stingers, and everything else required for combat. Now, in a large-scale conflict, we can quickly secure all of that equipment onto the ISV using simple materials like 550 cord and tape, and whenever we need something, we can remove it quickly and engage. It reduces the burden on the soldier because the rucksack can also be attached directly to the vehicle. For GRTC and my platoon's mission, it has definitely improved our operations. For us, the main focus has been avoiding roads and moving into concealed positions so we can remain undetected, stay hidden, and quickly deploy our drone systems for reconnaissance. The vehicle performs much better through wooded areas than I originally expected. It moves through terrain far better than a Humvee and has been getting stuck much less often. If you were bringing an ISV into combat, you would not drive it all the way to the front. Instead, you would likely move it into an observation position, dismount. And that reduces the amount of distance soldiers have to cover on foot. This means they arrive more prepared for the fight, carry less weight, and can focus on bringing only the mission-essential equipment into combat. The one improvement I believe should be added to the IV is a turret system. That would provide 360 protection and remove the need for soldiers positioned on the sides to constantly provide security. It would also give the vehicle greater defensive capability. Yes, we are ready to go. I'm Captain Wagner. I'm Hound 6, commander of the Strike Company for 22 Infantry. The main purpose of the Strike Company is to locate, fix, and attack enemy forces before our rifle companies within the battalion make initial contact. To accomplish this mission, we have received these new ISVs to provide an additional mobility capability. So far, they have performed extremely well for us. These vehicles can move through difficult and rugged terrain. They can climb over rocks, travel through mud, move through snow, and handle icy conditions even without chains. Overall, we are very satisfied and excited to have this new mobility platform. Another advantage is the ability to quickly load and unload personnel and equipment because the vehicle does not have traditional walls or barriers. You can place 9 soldiers inside the vehicle very quickly, much faster than loading or unloading an LMTV or a high-back Humvee. Beyond that, there is no delay when using this vehicle. You start it, press the accelerator, and move immediately where you need to go. The seat belts are simple. The seats can fold down or up when needed, and all necessary equipment can be stored on the vehicle's racks. Looking ahead to our upcoming force-on-force operation at JRTC, I believe these ISVs will allow our Scout Platoon and Lethal Unmanned Systems Platoon to move into locations where the enemy cannot easily follow. This provides us with a greater survivability advantage by allowing us to reach difficult areas while still observing enemy movements through our UAS platforms or through the eyes and optics of our scouts. Firepower is already integrated into the design. A top-mounted weapon station can support M240 machine guns, M2 heavy machine guns, or Mk-1947 grenade launchers. Side-mounted swivel points allow additional weapons such as M249s or M240s, giving squads the flexibility to carry the ideal firepower required for each mission. Its versatility also continues into deployment operations. The IV can be transported inside C-17s or C-130s, delivered by air using low-velocity airdrop systems, or carried beneath a U-60 Black Hawk through sling load operations. Stretchers can be secured to the vehicle's rollover protection structure using crab claw brackets, allowing injured soldiers to be evacuated quickly even while operating in hostile environments. Power is provided by a GM Duramax 2.8L turbo diesel I4 engine combined with a 6-speed Hydra-Matic 6L50 automatic transmission. It provides the strength, durability, and dependability soldiers require to move through challenging terrain while carrying a full combat load. If you're enjoying this video, make sure to hit that subscribe button for more content like this.